Okay, in this video we're going to look at what happens when we have simultaneous mod constraints. So I'm going to mention a few terms just so that if you see this referred to by other names, this all rings a bell. So each of these is, you might hear the term linear congruence. If you remember, this symbol is not equals but congruent. So you may hear the term linear congruences. You may hear simultaneous sort of equations with mods, modular arithmetic. This also has a very nice name called the Chinese Remainder Theorem. I won't go into the details because I don't think it's super useful for those of you that just want the application, but this is historically has a lot of related to this. So if you want to study this further, look up more stuff on the Chinese Remainder Theorem. What this does is basically, under certain conditions, guarantee you an answer for these problems and tells you how to get it. Okay, so what we're going to do is, first of all, explain what in the world this means. Most of you, if you're students, you're not going to actually see this unless you're doing some advanced math. What you will see is a problem such as Harry has some number of sheep. If he splits his sheep into groups of 3, there will be 2 left over. If he splits his sheep into groups of 5, there will be 1 left over. If he splits his sheep into groups of 7, there will be 4 left over, and then there will be choices. For example, how many sheep could Harry possibly have? Well, actually, in those conditions, you may just want to plug in the choices, but let's see how you would arrive at it without plugging in answers directly. So notice this is an abstraction of a more practical problem of dividing animals or dividing anything and having there be some constraints. So, we're not just trying to solve this. We want to make sure this works at the same time as all of these. Okay, so there are several ways to do this. I'll show you what I think is a pretty good, fast, practical method for these smaller problems. If you want to explore this further, like I said, go and study the Chinese Remainder Theorem. All right, so here's how I would approach this. We want to be extra lazy, so let's go to the largest number here, which is 7. Why 7? Because we're going to have to be doing a lot of guessing and checking. And if we start with the smallest number, we're going to be moving in steps of 3, and we're not going to be covering a lot of ground. So I'd rather cover more ground, so pick the largest step. So that'll be 7. So let's just guess. Well, what's the first number that leaves a remainder of 4 mod 7? Well, how about 4, right? 4 is congruent to 4 mod 7. The problem is we go to these, and unless both of them work, this is not correct. So is 4 the same as 2? Is 4 congruent to 2 mod 3? No, this would have to have been like a 5 or something. And also it doesn't work there. But as long as one of them doesn't work, that's no good. So we're going to start hunting. So let's just keep adding 7s. So our next guess is 11. So 11, does that satisfy any of these? Well, let's take a look here. 11 mod 5 happens to be 1, so far 11 works here and here. Now let's see, 11 actually also leaves a remainder of 2 when divided by 3, so it satisfies all 3. So what we have here is a bad problem on my behalf because it's too easy. So I'm going to make our life harder and make this a 1. Why did I just change the problem? Because I want to show you guys what happens in the case that it's harder, not in the case that it's easier. All right, so now we found something that not only works for here, but also works for something else. So now we could just keep doing this process till we hit something that's going to work for all 3, but that's a little too slow. So now we're going to move in bigger steps. Why bigger steps? Because now we can take advantage of the fact that this worked for 2 of them. So if you go back to GCF LCM, that video, what's the LCM of 5 and 7? It's 35. So let's now move in step sizes of 35. Why are we doing this? Because if we move in step sizes of 35, we will not affect these 2 constraints. In other words, we've already managed to satisfy 2 of them, and we don't want to satisfy this at the expense of breaking something that we already had that was good. Since 35 is divisible by each of these, it will leave these remainders unaffected. So in other words, we're just building on good stuff without breaking it to try to get more good stuff. All right, and 35 is a much bigger step size than 7. So in other words, we'll hit more numbers faster. Okay, so next number is 46. What is 46 divided by 3? Is that a remainder of 1? Yes, it is, right? It's 45 plus 1. So bingo, this works for all 3. So now the question is, are we done? Is 46 your answer? Well, 46 is one possible answer, but there's actually an infinite amount of answers. So what do I mean? Remember how we moved in 35s? We did that so that we wouldn't break our existing good solutions for these two. Well, if we move in a certain way, we can keep generating new and new answers without messing up any of these. So how do we do that? Now we get the LCM of all 3, which should be 105. And that's our magic number. If we move in step sizes of 105, either up and down, we can go negative, this will not affect the solution. So once you have a solution, whether you guessed it or did this formal procedure, now we can create an infinite amount of other solutions. And I'm going to put a K here. So what this means is this is just an integer. So it's some number multiplying 105. It could be a 1, a negative 1, a 2, 3, 4, 5. It can't be a fraction. So as long as we're moving in steps of 105 up and down from 46, we're going to create new solutions. So for example, 46 works, add one of these, we get 151. That's another solution. So let's show you guys I'm not lying. This divided by 3 leaves a remainder of 1. Divided by 5, also a remainder of 1. Divided by 7, that would be 140, 147, remainder of 4. So again, it works for all 3. I could add 105 again. So 256, and on and on. All of these would work for all 3. So if you see a question, they may not give you this as a choice. You may see some other crazier number, but also it's way more powerful to be able to create it and not just to plug it in. Of course, it's much faster just to check it rather than to figure out that this is to get it yourself. All right, I'll leave you guys there.